This is 11.1, sequences and series. It has a couple more topics in it, but we'll get right involved with this. It says that the definition of a sequence is a finite or infinite set of numbers listed in order. So we've seen sequences over the years, and it's just a list of numbers in a certain order. And typically we use subscripts like A1, so we have A sub 1, A sub 2, A sub 3, A sub 4. So the first number in the sequence, the second number in the sequence, the third number in the sequence, and that's what those represent, whatever number, whatever sequence this is. So let's look at some examples. So if I say write the first 4 numbers in this sequence, and again, I'm giving you like a little pattern here. So if n is 1, so that's really what that means. So if n is 1, 3 times 1, so I'm literally putting a 1 right there. So 3 times 1 is 3, 3 minus 1 is 2. So the first number in the sequence is 2. And that's if n is 1. If n is 2, so you substitute 2 into this n, and 2 times 3 is 6, 6 minus 1 is 5. And then we're going to substitute n equals 3n. So if we substitute 3n, we get 3 times 3 is 9, 9 minus 1 is 8, and then n equals 4 times, we're putting a 4 right there. 4 times 3 is 12. 12 minus 1 is 11. So those are the first 4 numbers. So again, if I gave you a sequence, you could see that 2, 5, 8, 11. You could see a kind of a pattern sometimes to be able to see what's happening. To be able to go to that. What if I ask the next number or the next 3 numbers in the sequence? And all I'm doing is finding the next number in the sequence. So let's look at another sequence. So here I have 3 plus negative 1 to the n power. So again, if n equals 1, so if I put a 1 right there, so negative 1 to the first power is negative 1. Negative 1 plus 3 is 2. So the first number of this sequence is 2. Now if n equals 2, well, if n equals 2, negative 1 squared is a positive 1, and then 1 plus 3 would be 4. Well, what if n is 3? So, well, that's a negative 1, and negative 1 plus 3 is 2. And then you can see that it's just going to keep alternating like this, depending on what the exponent is. That's literally all that's happening is in that sequence. You can see that, and just you got to look for things sometimes when it's alternating with an exponent. What's actually taking place in the sequence. All right, so here, what if I gave you a bigger function? It said write first 5 terms in the sequence. Well, again, if I put negative 1 in, so if n equals 1, so negative 1 to the first power, and then I'm putting 1 down here. So everywhere there's an n, I'm putting 1. Well, that's negative 1, and then on the bottom, I have 3. Well, what if n equals 2? Well, negative 1 to the second power, 2 times 2. Well, negative 1 to the second power is positive 1. 2 times 2 is 4. 4 plus 1 is 5. 1/3, 1/5. I want you to notice what's happening here. So n equals 3, so negative 1 to the third power times 3 plus 1. So that's negative 1, and then that's going to give me 7. So notice what's happening. 1, it's changing signs. It was negative, then it went to positive, then it went to negative, then it went to positive, depending on what the exponent is. And then notice the denominators, they're increasing by an odd number. So if I ask you to find the first 5 terms or 6 terms or 7 terms, you can easily do that. Now, I also want you to notice you can also come over to your calculator, and if you plug this function in, and then we're not going to care about the graph, but if we notice the table, so when I plug 1 in, I get negative 1/3. When I plug 2 in, I get 1/5. When I plug 3 in, I get negative 1/7, and then so forth. The fourth number, the fifth number, the sixth number. So you can always go to your table to do this. Sometimes, like the previous problem I did, I could do that quicker than plugging into the calculator probably, so it's not that big a deal. But sometimes looking at some of these big things, it's easier just to plug this in and look at your table. All right, so then you can find the first 4 numbers, 10 numbers, whatever it is, very easily. Now, a recursive pattern, so this is called, this particular recursive pattern is the Fibonacci sequence. So what it really does, it's going to use, a recursive pattern basically uses a previous number in the next number. So for instance, you notice the first number is 1, and then the second number is also 1, and then the third number, so you can see what I have here. So the third number is 1 plus 1 is 2. And I want you to notice what's happening. So here I'm bringing this here, I'm bringing this here, and then I add those together, that's 3. And then I bring this here, and I bring this here, and then my next number, I add those together, that's 5. I bring this here, I bring this here, and I add those together, that's 8. This here, bring this here, and you can keep doing the exact same thing, just literally the next number and this next number, add them together, and you can do the exact same thing, finding the next number, once you notice the pattern. So that's what a recursive pattern is. It uses the previous number in some way, not necessarily this way, but in some way that a recursive pattern uses the previous number. So I want you to be aware of that word. All right, now a factorial pattern. Now, if you've never seen this button, this little function before, so if I have n factorial, so if I have like 3 factorial, what that means is 3 times 2 times 1. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. You're counting all the way down to 1. That's what the factorial exclamation mark means. You're just putting, factorial means you're just counting all the way down and you're multiplying those. So, and by definition, by the way, 0 factorial is 1, just by definition. All right, so here, if I substitute these in, a to the 0 power, so 2 to the 0 power over 0 factorial. A to the first power is 2 to the first power, 1 factorial. To the second power, so 2 to the second, 2 factorial. 2 to the third power over 3 factorial. 2 to the fourth power over 4 factorial. That's what all of those mean. Okay, and again, I want to show you how to do it by hand, and then obviously the calculator is going to come in handy as well. So anything to the first power is 1. 0 factorial is just 1 by definition, so the answer is 1. So the first number in the sequence is 1. Here, 2 to the first is 2. 1 factorial is just 1, so the answer is 2. So the second number in the sequence is 2. 2 squared is 4. 2 factorial, again, 2 factorial is 2 times 1, so that would be 2. So the next number in the sequence would be 2. 2 to the third power is 8. 3 factorial, we've already done this, that would be 6. So you can reduce that. 2 to the fourth power is 16. 4 factorial, again, 4 factorial is 4 times 3 times 2 times 1, and that's 24. And you can keep going on with this pattern to see, what is the fifth number, the sixth number, and so forth. Let me show you a button on the calculator, though, in the math. If you go over to probability, the factorial button is right there. So if I wanted to do, 6 factorial, it's 720. So if it's a small number, it may just be easier just to plug it in. 3 times 2 times 1, 4 times 3 times 2 times 1, 7. If it gets up to 13 factorial, it might be easier to use that math button right there to get to the factorial. So wanted to show that to you in case if that's helpful. And then if I wanted to evaluate factorial expressions, again, you could plug all this into your calculator, but it's actually quite easy if you don't. So 8 factorial, just understand what that means. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Now notice once you write all that out, notice, when you simplify, all of this crosses out anyway. The 2 reduces with the 8, 4 times 7 is 28. So it actually crosses things out when you look at that. So if you always look at this right here, what's missing between, what's the difference between that? Because all of this crossed out, and really all you have left is 8 times 7. So same thing when I go to this next one, 6 factorial divided by 5 factorial. The only difference between that, I could write that out if I wanted to, 6 times 5 times 4 times 3 times 2 times 1, and then write 5 factorial out, 5 times 4 times 3 times 2 times 1. But the only thing that's going to be left over is a 6. And the same thing with 3 factorial and 2 factorial. If I wrote 2 factorial out and 3 factorial, the only difference between those is an extra 3 on the bottom. So I know the answer is 2. So, the same thing, the same progress as you go through this, n factorial divided by n minus 1 factorial. Think of what is actually taking place here. So whatever n is, we don't know what n is, but this number and then n minus 1, what is going to be the difference between that? So notice if I had 6 factorial and 5 factorial, this number is 1 less than that. So the only thing that's going to be different is that number. Okay, that's the only thing, because all of the other numbers will cross out. So here I know n factorial, if whatever number that is, if I listed all that out all the way to n, and if I listed n minus 1 factorial, list all that out, whatever that is, I'm going to have all the way to n minus 1. So this is going to be n minus 1, and then n will go all the way to n minus 1, and all of that will cross out, so the only difference is the n, whatever number that is. All right, now let's look at the last thing, sigma notation, or summation. So this little symbol right here, it's a funny looking E. What you have is a sequence or a series that you're going to be doing all the way from the first number till this number, and whatever that is. So for instance, let's look at some examples. So here x is 1, it starts at 1 and it goes to 5, and this is a summation. So it's not just a series, but it's a summation. So literally you're going to plug 3 times 1 in, then 3 times 2, then 3 times 3, then 3 times 4, and then 3 times 5. So notice I'm going from 1, 2, 3, 4, 5. I'm going from 1 to 5. And then I'm just doing that. And then you still have to add them together, but that's really what you're doing. And the same thing with this one. You're going from 3 to 6. So again, this is your starting spot. This is your ending spot. So literally 1 plus 3 squared, 1 plus 4 squared, plus 5 squared, and then 1 plus 6 squared. Yeah, so that's how you do it. You can do it manually. Now there is a summation button on here. So if you go to Math and go to Summation. So if I did this one right here, so let's do x equals, we're starting at 3. Oh, let me go back to here. X equals 3. So I'm doing the last problem here. So 3, and then I'm going all the way to 6. And then I could substitute this function in, 1 plus x squared. So I wrote it out, and then I can just let the calculator do it for me, add all that together, and it gives me 90. So that's how you do sequences and series, and then, of course, I had, threw the summation notation in, because now we're talking about when you start adding the sequences together, the summation of it. So, and I also showed you how to use the calculator on both the factorial and the summation.